Good morning still, everyone. My name is Evan Simpson. I'm a member of the AI Guild, and I'm a data science enthusiast and evangelist, and I will be your moderator here for Dr. Nicholas Hoff's session. Dr. Nicholas Hoff is a machine learning expert for freelance projects and the founder of New Approach Technologies. He's been in the field since 2011, and Nick holds a Master of Science in Aerospace, Aeronautical, and Astronautical Engineering from MIT and a PhD in AI from Harvard University. And a couple of things before we get started, I just want to remind you all that we are recording. So if you don't want your face to be recorded, please be sure to shut off your screen. Also, please, please, please ask questions via the chat. I'll be collecting them and we'll be sure to ask Nick all of them. Now, without further ado, Nick, the floor is yours.
All right, thanks for the introduction, Evan.
Welcome.
So we don't have a whole lot of time here, so I'm just gonna ask you, Evan, when I'm presenting, I'm gonna be full screen. So if I just go blabbing and blabbing, and if we go past 15 minutes, then just raise your hand and shut me up so we can go on to questions, because I don't wanna just keep talking and talking and have no time left.
Sounds good.
Let's dig into it. Okay, I'm gonna do that. Share screen. Oh, could you enable participant screen sharing, please?
Go for it.
All right, we'll do that. Share. Okay, how's that look?
Looks good.
All right, so data science and banking, let's get into it. So yeah, New Approach Technologies is a freelancing firm I set up to do go into companies basically and do their data science and their machine learning. I go meet them, and kind of goes from just consulting kind of issues where they ask me questions, what can data science do? We've heard about this thing, through to building prototypes. We do sort of exploratory analysis where they give me their data and say, hey, what can we do? And I build some prototypes and give them some kind of pointers about where they might go in the future, all the way to building kind of production systems. That's what I'm gonna go into today. This is just a bunch of the kind of fairly widespread applications that I've done in the world of banking, which tends to be where I've mostly worked. Not that I set out to do that, but that's where my clients tend to be. I'm not going to go through all these. I'm going to focus on the invoice classification project today. So what I thought I'd do is, you all, I looked online, seem to be a somewhat informed audience. So what I'm going to do for the presentation is lay out the invoice classification problem that SG came to me with, Société Générale, that they came to me with, and then instead of just going straight ahead to what I did, I'm going to talk about some of the machine learning techniques that I thought of trying, why they worked, why they didn't work, and then we'll get on to the final thing that's running in production now, and some of the more interesting points about that. Okay, so let's get into it. So here's the problem. SG have one branch of the giant, international corporation that is Société Générale, runs a corporate car leasing operation. So they own a bunch of cars, and other companies come to them and say, we want to rent 5 cars or 100 cars for our employees. So SG owns the cars, and that means SG is responsible for the maintenance. So a car goes into a maintenance shop, and that generates an invoice by the maintenance shop. The invoice goes to SG, and SG has to decide whether to pay it or not. This invoice here is obviously not one of my clients' invoices. I just grabbed this off the internet. But basically the idea is you get this invoice, and there are people sitting in rooms who do this all day and are experts, and they press pay, don't pay, pay, don't pay. So what we need to do is get the invoice PDF, extract the various fields from the invoice, identify which ones are relevant, train a classifier on them, and then issue payment recommendations on new invoices. Now, the problem of extracting fields from the PDF is a very difficult, I'll say extremely difficult problem. There's a lot of work being done on it, but that is a frontier research project at the moment. There are some companies that kind of claim to do this. There are even services in Amazon that Textract claims to do this. I haven't found one that works well, and I haven't seen it used in the wild. Now, in this project, they already had the invoices already parsed by another procedure that they do, which is amazing, but not relevant. So basically, when we get invoices, we can look at them like this. So all the data is kind of parsed out for you in this nice XML format. Okay, and now, so what we need to do is take all this data, stick it in a vector, and the labels are pay and don't pay, and SG gave me a bunch of years of historical data of, the invoices, the images, the XMLs, and the payment decisions that the people made, basically the labels, hundreds of thousands of them, and I can use that to train my classifier. All right, so they come to me with this problem. I say, no problem. Sounds like we can do that. So the first thing you might think of doing is just look at the image. You build an image classifier. You build a convolutional neural network. That failed massively. That did not work at all because the images are way too big. Thousands of these images, they're high quality scans, thousands of pixels, and they have to be big so that you can read the text. But CNNs don't work on pixels this big. The math works, and I tried building a CNN, to just take an image in and build a binary classifier. That predictably didn't work because the images are just too big, the models are just too big. So then I thought, well, maybe can I just to see if this is ever going to work, can I extract something from the invoice, maybe the vendor ID or the grand total? That sort of worked, sort of didn't. It's really slow, as I say here. It took 10 hours to train on a V100, which is at the time was the beefiest GPU you could buy, not that I bought one. And it was very low utilization. The reason is that it took so long to push this huge image onto the GPU and the huge model onto the GPU, and then in a millisecond, but in a very short amount of time, the GPU crunched the matrices, and now you have to wait to serialize them all back off the GPU onto the CPU to calculate the next round, and then serialize it back over to the GPU. The V100 has 900 gigabytes per second in memory bandwidth, which sounds like a lot, but we're dealing with images that are just too big. I'll say that the new, if you're following this, the new GPU coming out of NVIDIA, the A100, the Ampere architecture, is pushing the memory bandwidth from 900 gigabytes per second out to 1.6 terabytes per second of memory bandwidth, almost double. So that's, if you're looking in the new GPUs, I know their spec sheets are pretty big, but that number caught my eye, the memory bandwidth. Okay, so image processing, probably not going to work. So now let's use the pre-parsed data, and we'll just stick them into a neural network. There's a bunch of work to do to pre-process the data. We have to, the vendor IDs are not really integers, so we can't really just use those numbers as is. What do you do with text? And so we have to do a bunch of pre-processing. We can get into if you guys are, if that's what you want to talk about. But yeah, put all these as inputs to a neural network and build a binary classifier. That kind of worked, and if I had time, I would like to work more on it because I think it's a promising area. But when I was exploring options, this one, again, sort of predictably, wildly overfit. So in the training set, almost all the invoices are paid, which you might, kind of expect. Most invoices are correct and legitimate for work that actually happened and are correctly formed, and SG pays them, over 95%. So that's a wild class imbalance, which is a problem. And so the neural network could achieve excellent performance by just ignoring the data and say, always pay, and you get 95% accuracy. Great. But that's not really what we're looking for. There are things we could do about that, but I said, well, we'll leave that for later. So the next thing I thought was, well, let's sort of jettison all the modern, machine learning stuff and do a straight TCA. I don't know about, I'm not an expert in car leasing, but I can guess what you might want to look at when you decide whether to pay an invoice: the amount, the vendor, what kind of repair was done. I also did some computed features like, is it a Friday? Guessing maybe repair shops would be a little more lazy about filling out their invoices on Fridays because they want to get home, so maybe they would make mistakes. And could I explain the labels with high accuracy using the features or any linear combination of the features that I had guessed? Answer, not really. Again, that's sort of expected, because if it were possible, then the people who do this for a living, they know much more about this than I do, and they would have seen these effects, and then the problem never would have gotten to me, right? You wouldn't hire me if you already know that this one vendor is always a problem or something like that. So I tested this, and there were some ways forward. I thought, well, I could get some better features. I had some ideas of what might work better, but I thought I'll leave it alone. If I do more feature engineering on this problem, I'm basically just hand designing an algorithm. I'm trying to recreate the human expertise in my own feeble mind, and why don't I just talk to the people? And at this point, it's just a sideways or kind of a backdoor way of trying to hand design an algorithm, which I didn't really want to do. I think it's too complex. So what did I end up with? Good old Kmeans. This is the next thing I tried. Of course, it worked. It's an algorithm from the 50s out of Bell Labs in the 50s. It was republished in the 60s. So this thing is 60 years old, 70 years old. Basically what you do, maybe you guys all know about this, so I'll go quickly. You just take each feature in your vector and find the 3 most similar invoices to that feature. So, you know, I have this, do I have another invoice from vendor 76138 with the closest total, the same type of repair, the closest date, etc., and find the 3 most similar invoices in the training set and basically have them vote. In the case I have on the slide here, all 3 of those invoices were paid by the people, so I'll pay this invoice. You know, if 2 of them were don't pay or 3 of them were don't pay, then you predict don't pay. And that works pretty well. Basically what it does is embeds each invoice in a large space, and that, you know, this, I'm projecting it down onto 2 dimensions here, but it's this large space, and this plot is a little. This is just to give you an idea. Yeah, so a new invoice comes in, you check the nearby invoices in your high dimensional space and make a prediction based on the nearest ones. That's Kmeans. One of the neat benefits that you get is that similar invoices tend to cluster together. So I have fuel invoices labeled up there. I didn't have to build a classifier. I didn't have to build an explicit classifier. It turns out that fuel invoices tend to cluster in this space because a lot of their features are similar, which has the nice benefit that when a new invoice comes in, if it's a fuel invoice, it will be compared to other fuel invoices, and I kind of get that for free, which was a nice benefit. Okay, there's this issue of precision versus recall. So very briefly, recall is what fraction of the invoices, on what fraction of the invoices was a prediction possible? And then precision is how good was that prediction? So if I want to make, so my first bullet point there, 98% on 75%, what that means is the first classifier I trained had a recall of 75%, so it made a prediction on 75% of the invoices, and that prediction was 98% accurate. So I built that classifier, I thought, hey, this is pretty great. I went to SG and they said, yeah, it's not good enough. And it actually makes sense. In retrospect, 98%, that's 2% error, 1 out of 50. And we really don't want to be incorrectly paying or incorrectly not paying 1 invoice out of 50. So I went back and I tweaked it for higher precision at lower recall. Now 99.7% accuracy on 40% of the invoices, that 40% looks pretty low, but you know, any fraction of the invoices that you can automate, you know, we're almost doing half the invoices, that saves people a lot of time, and that's a real win for the company, because then the people are free to do the more interesting work. They don't want to be sitting there pressing pay on all the boring invoices, and this one can handle, you know, 40% of them at good enough accuracy. I mentioned the class imbalance problem. Now, one of the benefits of Kmeans, as opposed to big, heavy, you know, GPU trainable algorithms, is that I can do it really fast on my own CPU and my workstation, train it up really fast, and I can do these tweaks when I talk to the client about, you know, oh, we like, you know, they say, we like your algorithm, but can you tweak it this way? I say, yeah, no problem. I go back, I change it to, you know, I can make this precision versus recall tweak. There's one other thing that I'll say before I wrap up. How are we doing? Oh, man, I'm going fast. All right. I changed the algorithm slightly so that instead of predicting pay or don't pay, instead of those being the 2 outcomes, I changed it so that the 2 outcomes were pay and no prediction. The reason is that, I might as well get into this now, there's this issue of would you rather, if you're going to make a mistake, would you rather incorrectly pay an invoice? That means you pay a shop you shouldn't have paid and you lose money. Or would you rather incorrectly not pay an invoice? That's where the invoice was correct and you just don't pay it. And where SG would rather fall in that scale is a decision for them, not me. And I don't know the impact, what's the financial impact and business impact and customer relationship impact of each of these. It's a question for them. So I brought it to them, we talked about it, and what they said they'd rather do is they never want to pay an invoice that they shouldn't pay. But they said both, like they never want to pay an invoice they shouldn't pay because then they lose money. But they don't want to make the mistake where they incorrectly don't pay an invoice. So, well, they said, yeah, well, we don't want to make either kind of mistake. Sounds impossible. So what I did is that's when I changed the outcome. So I decided to train a classifier that it only ever says pay or don't know, and train that to minimize false positives. So if it says pay, then it's really, really sure it should be paid. That's the 99.7%. The other is no prediction. And so that might mean don't pay. It might mean that it thinks it's very likely to not be paid. Or it might mean that it just can't make a determination because there aren't enough nearby invoices or whatever. And the system that I built just sends those to the people, to the regular humans as it is currently done. And that kind of solved both problems. That way we get 99.7 accuracy on pay invoice, and you never don't pay an invoice that you shouldn't pay because, well, if you make that mistake, it's the people who made it, since I kicked those decisions over to the people. Yeah, so I spent a while doing this project, showed them the prototype, and then wrapped it up into, I kind of hardened it. It worked on my machine, but I wouldn't call it production quality code. So then I spent some time hardening it up, a bit of fuzz testing on it, removed some dependencies that I didn't need so that it wouldn't fall over for that reason, wrapped it up in a web server, and I talked to their IT people about getting a server to run it on. And there's a bunch of engineering. Once you get all the data science done, which is kind of the fun part, there's always a bunch of kind of engineering and IT related work to make a robust system actually running in a company that, I did this project a while ago and it's still running and saving them money today. So there's all that to do too. So yeah, my last slide here is about some sort of stuff I've learned over my time about how to have a successful ML project, where successful might mean, well, let me go into it. So success is defined between you and the customer you're working for. So going in, they might ask you, we have some data, we want you to just tell us what's possible, right? You're a smart guy, you know about machine learning, this thing is new and we keep reading about it, and what can we do? And if that's the project, then I do it and I report back and I write a report saying, or more likely tell them, this is what we can do and what we can't. And that's a successful outcome because I've answered their question. Or they come with a crisp thing like, yeah, here's our data, please build a classifier, and they're going to measure the success of the project by did it get done on time and on budget and how accurate is the classifier. So the most important thing is to have a clear goal going in. This thing about clear data that we heard earlier, that's really true. Spend a lot of time on clean data, because if you don't clean your data, nothing good will come out of it. And it's important to understand, for clients to understand that that's necessary. Yeah, and then frequent communication as always. Yeah, I think that's all from me. So I want to stop talking now and get on to everyone's questions. Let me stop sharing. Okay, get rid of that.
Thank you very much, Nick, for that incredibly engaging talk. Are you going to make those slides available later? Would it be okay if we share those later with everybody?
I'm willing to.
Fantastic.
Yeah,
Cool.
I can post them. I don't know how to post them. So if you want to post them, go ahead and post them.
All right, sounds good. And a couple of quick questions that we have here is, one of my first ones is just starting all the way back in the beginning when you were saying that you were working as freelancing and going into companies. How do you go about getting clients?
Yeah, this is a common, it's the problem everyone has. And when I started this, I had that issue, like, I'm just a guy. How am I going to go to a bank and say, you should give me your data and like, trust me, I'm just a guy. I made a website, I printed business cards, I started going to meetings and stuff. None of that did anything. I don't think anyone's ever seen my website. I don't think I've handed out business cards. I don't think anyone ever looked at them. what I did was I just started going to meetups and industry events and just putting on my shoes and walking around the city and meeting people. And it's slow and arduous. And at some point, you have to convince someone to trust you. So you do one project. I did one project, and the client was happy with the result, and then it rolled on from there. They talked to their friends, then their colleagues, they contact me. I do good work for them. It rolls on from there. So I think all of the marketing I've done has been completely useless. It's just word of mouth between clients talking to each other.
Uh, Speaking of clients, Aang asked a fantastic question. How did the client react to the process of you trying different models and then finding one that worked? Because I was wondering the same thing, was how involved was the client in deciding what kind of model you were going to ultimately use?
Yeah. In this particular case, the client I was working with was really interested in all this stuff, and they thought it was really neat, and so they were kind of happy and were eating it up when I was telling them about techniques I was using. Other clients kind of don't care about all the details, and they just want the final result, and that's totally understandable and fine. So in this case, yeah, I told them, oh, I tried this, it didn't work, and they were saying, oh, why didn't it work? And I read about this other thing on Python, and can you try that? And so with them, it was really a back and forth, and it was fun. And but if there was another client that was more just kind of purely business oriented and just wanted the result, maybe I wouldn't have gone in, I wouldn't have, not hide it from them, but I just wouldn't have emphasized, I tried this, it didn't work. I tried this, it didn't work, because you kind of don't want to be telling clients all the stuff that doesn't work. So yeah, I think it's an issue of just kind of feeling it out with each particular client.
Speaking of that, I was wondering about how you managed expectations of clients, because like you said, but I saw this in The Economist. They were talking
Exactly.
about GPT-3, blah 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 blah, and I was wondering how do you engage clients with maintaining expectations?
Right. Well, so I guess there are two answers to that question. The first is just straight up clear communication from the get-go. And if you have to say something that you think the client isn't going to want to hear, you have to say it the first thing you say clearly and straight ahead. No, I don't think that's possible. Because if you say, no, 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 we'll try it, we'll check, we'll see, then you try it, it doesn't work, and now you've gone a lot of time and spent their money and they're unhappy. So if you don't think something's going to work, say it. And if you want to try something, then say that and go ahead and try it. It is true that sometimes clients have magical expectations of machine learning because it is legitimately awesome, and they read about it, as you said, in the in-flight magazine, and they think, well, we should want some of that magic here. And what I've learned is that I almost never need any of the techniques you read about in the popular ML kind of press. When I actually get into a client's organization and start talking to them, and then get to the end of the project and see what I actually implemented for them, it's almost always simple stuff that solves low-hanging fruit that I'm amazed that they haven't solved before, right? So they don't need the super awesome, state-of-the-art techniques. Usually, sometimes they do, but I can get a lot of strong impact for a lot of clients on clean data, linear regression, K-means, and basic neural networks. So yeah, a lot of times they don't need the magic.
And then, another quick question that I have regarding that is, how often do you reject clients because their expectations are just unrealistic, or because what you're saying is that, well, we could just go about it this way?
Um, I don't think I've ever rejected a client in the sense where they say, you know, we want you to build this. And I say, nope, not going to build that. Goodbye. There have been times, I say times, I think there was one time where we did an exploratory project. Turned out that it looked like what they wanted was going to be possible. This was the database deduplication project. A client had two databases of almost the same, but not quite the same data, incompatible, really thorny problem. And they wanted to split them apart. So I looked into it and I said, I think it's possible. And so I built the deduplicator for one database, and then they said, that's great, can you do it for this other database? And I looked at the new database, and for technical reasons, I thought, no, this one's not going to be possible. And they said, really? Can't you just do the same thing? I mean, you already wrote the code. Can't you just try it again on this other one? And I said, no, I mean, I can tell it's not going to work. The database is different. It doesn't matter why in this case, but in the end, I said, look, I don't want to just take your money. I know it's not going to work, so no, can't do it.
Now, to everyone out there, we've got about 5 minutes left, so please be sure to get those questions in. And oh boy, just got a big one here from Moha. Thank you so much. Quick question. The question, you can see it in the chat, Nick, if you want to go ahead and read it as well, because there's a lot going on there.
Hi, Moha, by the way.
I'll go ahead and I'll read it aloud. How did you gather data? How did you convince them to give you the data?
Okay, actually, it's a bunch of bullet list questions. All right.
Yep.
Let's go through them one at a time. So we have 5 minutes left. Is that right, Evan?
Right about there. Yep.
All right. This will be the lightning round. How did you gather data? They sent it to me. Either they give me a login to their servers, or they encrypt it on a USB stick, or somehow they give it to me securely. Is that what you mean? Like, how do I literally get it? They find some way to transfer it to me. How did they get convinced to give you their data? Yeah, that was surprisingly easier than I thought. Once they've decided to work with me, then that's the hard part. Then once they've decided to work with me, then giving me the data is just some annoying IT stuff, right? They have to give me the whatever decryption keys and stuff and a login to their system. So it wasn't, you know, after we've had a couple of conversations, it's not hard to convince them to give me the data, as long as I promise to, you know, treat it carefully and not put it out there on the internet and all that. Did you use OCR? Nope. Which package did you use? Nope, didn't use any OCR. It doesn't work well enough. How did you deploy it in your pipeline as a reproducible one? Yeah, I didn't use OCR, but the ML model is ultimately, you know, statistical, and so it has to be reproducible. Kmeans is reproducible if you don't change the underlying data and you don't change any of the pre-processing. You'll get the same answer every time. Now, that's an interesting question. I don't actually know how much they care about that. I've never thought of that before. They might really not like it if the same answer goes in one time and says yes, and the next time says no. And then I'd have to do a lot of explanation about, no, it actually makes sense because of blah, blah, blah. Interesting question. I've never used okay, let's keep going. Did you try NER for solving the problem? Don't know what NER is. What's that?
Named entity recognition.
Named entity recognition.
Yeah, it's natural language processing technique.
Nope, didn't use that.
Fair enough.
My pre-processing all my pre-processing was just categorical on text strings. Like that's not true, actually. It was a bit more complex with a description of the type of repair. Okay, why did you choose Kmeans? It's the simplest thing that I tried that worked after trying all the other things that didn't work. Can you scale your model for other kinds of problems, or only works for this kind of problem, for this kind of invoice? There's every reason to expect that the similar thing would work for different kinds of invoices. Although I guess I shouldn't say that, because the further away you get, you know, this is about car rentals, the further away you get, if I want to try to do invoices on, you know, you order takeout, you order delivery from some restaurant, and now you have a bunch of data about people and what they ordered, and I would not bet that this algorithm will work on that. Even if mathematically it looks the same, the data is going to be different, the failure modes will be different. So yeah, I wouldn't bet on it. Yeah, okay, that was it.
Went ahead and sent the slides to everybody. So those are please enjoy. And then one last question, though, that I'd love for you to talk about is you mentioned earlier about I think it was the new NVIDIA graphic card or memory chip. I can't quite
The
remember.
A100, yeah.
Thank you.
Yeah.
And so speaking of that, what are these types of new and emerging things, hardware or technique, that you think that, I understand what you said earlier about start simple and then get more complicated, but what are some of these new and emerging things that you think that people should be aware of?
Yeah. I try to spend some of my time, reading research papers, and I have a group of other researchers, and we get together and read papers and try to keep up with the modern stuff. And when I'm not tied down to a client and I can let my mind run and code for fun over the weekend, what I really am looking forward to in the next, it's been growing really well, but especially in the next couple of years, is generative modeling. This is where you want to model. You have a big distribution of data, like images of whatever, something, cats or something, and you want to model this distribution, but it's too complex. So what you do is you try to build something that can generate a new cat image. And there's some really fascinating ways to do this. And you would think, well, why would generating an image give you like insight into the stats of the distribution, and why would that be useful? It turns out that if you build a generative model, you can use parts of the model for other classification tasks, and it can work with unlabeled data, which is amazing. So yeah, I'd really love to do a project on generative modeling in the future. That's something I've got my eye on. It's going to be awesome.
Okay. We've got about 5 minutes left, everyone, so go ahead and get those final questions in now. And then another quick thing that you were talking about was about just trying to figure out how to balance research with solving real-world problems. How do you strike that balance?
Well, first of all, I guess this is clear, but anytime a client asks you a question, they get priority. So sorry, I'm busy playing is not an answer. For a while, it hadn't been a problem because I didn't have enough clients to keep me busy, so I'd spend my other time reading papers. Sometimes I really am. I could work for clients full time, and then you just have to. It's an issue of deciding when do you not take on a job, or tell a client that some project isn't going to work. But the thing I guess I would caution people against is doing only engineering. If you only do kind of client work, what real work, productive work, it's not going to be a year or two until you're behind the times, because this all moves so fast. So it's important to pick up papers once in a while, beat your head against the math, learn it at a deep level, and yeah, don't just use the scikit-learn example code.
Speaking of scikit-learn,
Yeah.
I've got a great question here from Stas, which is, and I'm sorry if I said your name wrong, which is, do you only use stable data science libraries, aka scikit-learn, for your work, or do you have some private code where you adapted recent research papers that haven't been adapted into the mainstream libraries yet?
Yep. For code that I'm going to deploy into a client that I expect to run beyond my engagement and is a real like production deployment, I only use stable libraries. I don't use the testing version, nightlies or anything. I use stable versions. It doesn't matter if it's old, it's got to work. It's going to be maintained for a while, and I can't use Joe's awesome GitHub repository because I really don't want an international bank calling me 2 years later and saying your thing failed because of Joe's GitHub library. So only stable code, established libraries for production software. For exploratory projects, the sky's the limit. Then I just bust out PyTorch and use the whatever I can come up with. Anytime a new optimizer comes out, yeah, I'll stick it in, try it, and see what happens. I probably wouldn't put a research, new optimizer that comes out in a research paper. I don't think that I would run that inside a company. But if a client comes to me and says, we have this data, do you think it will work? Yeah, I'll try all the new stuff and tell them yes or no, depending on bleeding edge results.
Last question. Currently in industry, this is from, and I know I'm going to say your name wrong, so it's in the chat. I'm terribly sorry.
Aditya. Hi, Aditya.
Currently in industry, especially dealing with images, what percentage of total projects use feature engineering versus deep learning?
I don't know.
If you had to guess.
Well, I can't tell you in all of industry. I can tell you in my experience. Oh, wait, you asked specifically dealing with images. Mm-hmm. All deep learning on images. No one does feature engineering on images. I mean, no one that I know of, I haven't heard of projects doing that. It's too hard. That was image processing in the 90s and 2000s and 2010s. Try to determine if an image, this is like, you have a picture of an apple or an orange and you try to determine whether it's an orange by counting the number of orange pixels. That doesn't work. That's all deep learning now.
And with that, we're at the end of our session. Thank you so much to everybody for attending. Thank you so much to Dr. Nicholas Hoff for his wonderful presentation. I have put the link to the next data lift, which will be November 27th at the exact same time. So if you would like to share, please go ahead and get in contact with the AI Guild and definitely do attend. And with that, thank you so much to everyone.
Thanks for coming, everyone. This was fun. Feel free to hit me up, email me if you want, and it's fun to talk about all this stuff. So thanks for coming, and thanks, Evan.
You're very welcome. Cheers, everybody. Bye-bye.